Good morning and happy Monday. We are going to start by, I'm going to start by putting up the answers from the homework on Friday. So here they are. And I would say there weren't a ton of issues. We didn't have very many people that did it, but the people that did do it, here was the component form, and then don't forget to simplify your radical. So this is actually your final answer here, 2 root 5. Here's your component form, and here was your magnitude, component form, magnitude, component form, magnitude. I was real pleased with 17 and 18. You guys did well with those, not letting them confuse you with the direction. And then 22, don't forget you're going to do terminal minus initial, terminal minus initial. So here's your final answer, and here's how it should look simplified for magnitude. Okay, so that's what you should have for your homework answers if you want to go back and look at that again. And now we're going to learn something new. It's called unit vector. So it's kind of like, the unit circle was called the unit circle because the radius was 1 unit. Well, it's kind of the same thing with a unit vector. A unit vector is a vector whose magnitude is 1. And then what do we remember magnitude means? Magnitude is the length. So remember, a vector has to have both magnitude and direction. Those are the two components. So we don't care about the direction at all with a unit vector. We do care about the length. Okay, so my first question to you is a vector with the components -3, 4 a unit vector? So basically, does the magnitude equal 1? So we could sketch it if we wanted to. So let's first do that. So -3 means we're going to go to the left 3. I'm going to start it here. Well, let's use it. Excuse me. Let's use a different color. Start it here. All right, and now we're going to go up 4. Okay, so then our end point would be left 3, up here, and so then that's our vector. Okay, so does it have a magnitude of 1? The answer is no. I hope pretty quickly you can see if we were to draw our right triangle like this, this would be -3, this would be 4, and then I hope you can tell this is a 3, 4, 5 triangle. So the magnitude of this vector u is 5. Okay, and that's if you want to do the Pythagorean theorem. It looks like this. Okay, so there's our magnitude. So how do we, if it's not a unit vector, what do we do to make it a unit vector? So basically what we're going to do is we're going to do something called scaling back. Okay, so we're going to scale back the magnitude. And how do we do that? Well, the way that we're going to do that is if we want this unit vector to just be like this long, 1 unit exactly, what are we going to do to get that to be just 1 unit? Well, what could we do to 5 to get it to equal 1? We just divide it by itself, right? So we're going to scale back the magnitude by dividing by itself, or the magnitude itself. Okay, the magnitude. Now, with you scaling back to get 1, you also have to then scale back the x and y components, okay? So then the way that we're going to do that is we're going to just do the same thing. If I divide the hypotenuse by 5, I have to divide the other sides by 5 as well, because I have to keep it proportional, okay? So basically, all you have to do is divide the magnitude by itself, because then, check, we get a magnitude of 1. But once you divide that side by the magnitude, you have to divide all the sides. And so here's how we write this. We call this with a little hat, that's the unit vector. So the unit vector of this vector u is now, so the component here is now -3/5, and then up 4/5. Now that has a magnitude of 1. Okay, I'll go into a little more detail in just a moment. when we do some practice examples. So just FYI, if it's not a unit vector, then we need to scale it back, which basically just means divide by the magnitude, and you have to do that to each side. Okay? All right, now we're going to see some problems that involve the letters I and J. So I is the unit vector in the X direction. So that means like here. Now remember, it's a unit vector, so that means it has to have a length or the magnitude of 1. So only one, space. If I go beyond this point right here, that's more than one unit vector, or more than a unit. Okay, so that's I, if it's in the X direction. Now, if I went like this, what would that be considered? Well, that would be considered negative I, right? Because it's still going in the X direction, it's just going the negative way, okay? And then I can do J, it's the Y direction, so from here to here, that's J, and then from here to here would be negative J. Now, we could keep going. You could do something like this. So what would that be? Well, that would be 2J, okay? Or I could go, several more units. Let's say I extended this, and I could go something like 1, 2, 3, that's 4J. Oh, no, excuse me, for I, because it's in the X direction. Okay, so when you see I and J, just understand I goes with X and J goes with Y, because it's like alphabetical, and I represents one unit vector. So if I say 4I, that means 4 unit vectors in the X positive direction. Okay? Okay, so now it says, here's a practice problem. It says, rewrite this vector over here, let's call it U, in terms of I and J. Okay, so we need to figure out how many I's and how many J's are in this vector here. So basically, you just need to figure out how much you need to go right or left and then up or down. So if we're starting here, we're going to go right some number of units, and then we're going to go up some number of units, okay? So technically, does that ring a bell that it kind of is just basically like your component form? So I'm going to show you first, it's easiest just to do component form and then switch it into I and J. And if you remember, terminal minus initial is how we're going to get our component form. So we're going to go 7 minus 3, and then 9 minus 4. So our component form for U is going to be 4. I just had to take a second to subtract that in my head. Sorry. 4, 5. Wow. Okay, now, because I corresponds with X and J corresponds with Y, you're literally just going to put the I with this one and the J with this one. So another way to write this would just look like this. You take the pointy parentheses away. So there are 4 I's. We went to the right 4 units. Okay. And then we went up 5 units. Okay, so it's 5J. Now, instead of putting a comma between them, you put either a plus or a minus. And because the 5 is positive, you're going to put a plus. If we had gone down, then you would put a minus. Okay, so basically, once you have your component form, you're just going to take the pointy parentheses away and the comma, and you're just going to throw I and J in there. Okay? All right, we're going to do some practice problems now from some bookwork problems. I'm going to do the ones in pink, and you're going to do the ones in blue. And the reason I'm doing this is because they're like, I'm doing the left, you're doing the right, the odds, and then you're doing the evens, is because they're going to be real similar, but I don't want to lead you astray. Okay, so I'm going to do 1, 2, 3, 4, 5, and you're going to do 5. Okay? Now, I've already drawn them just to save us a little time so you didn't have to wait and watch me. But let's take a second to read the directions. It says, in 39 through 48, find a unit vector in the direction of the given vector. So we want to basically do that scaling back thing. Okay, so we want to find a unit vector that's basically the same direction as what we are given, and then it says verify that the result has a magnitude of 1. Now, this is the part that you're not going to be able to show me through Google Form, but that you might want to do to just make sure that you're on the right track. Okay? So, our directions change down at the bottom when we get to 53 and 54, but we'll just start with 39 through 45. Okay. So, I went ahead and wrote the simplified directions, okay? So it says find the unit vector and then verify. So I went ahead and drew it, but I hope that it kind of looks familiar to y'all, that 3, 0 means we're going to go to the right 3 units and up none, okay? So this one is actually probably the easiest one because we're not having to draw a right triangle at all. We know what the magnitude is. How long is this vector right here? Well, it's only 3 units, right? So it is not a unit vector, but in order to find u hat, the unit vector, we just need to scale it back. So if this vector u is 3 units, we just want to scale it back by dividing by 3. So essentially, how long is this green vector now? It's 1 unit. Well, 1 unit in which direction? It's going to the right, so it's going to be positive 1 and then up none. So if it's perfectly horizontal or vertical, you don't really have to do much math. You just need to kind of use some common sense. Or you can use math if you want, and I'll show you. So this original length was 3 units. So we're going to divide each of the components by 3, and then we're left with the green. Okay? All right, so this is technically my final answer. Now, it says verify that the magnitude is 1. Well, I could just say, look at the picture. There you go. I'm going to show you in the next example how you actually can do it mathematically, though. Okay? All right, the next one's not so straightforward because it's not perfectly horizontal or vertical. So I can't tell you what this magnitude is just looking at it. So I'm going to need to do Pythagorean theorem. Okay, so I'm going to go -2 and 2. So my magnitude of V is going to be -2 squared plus -2 squared. And then 8 can break down into 4 times 2, and the square root of 4 is 2. Okay? Now, that's not my answer. That's not my final answer. That is the length of this right here. Our length of this vector is 2 root 2. Well, I want that to find a unit vector, which would be like, this long. I want to scale it back, so I need to divide by itself. So I'm going to divide this by itself, and then that will give me 1, what I want. Okay, but if I do it to this one, I have to do it to this one, and I have to do it to this one. Okay, and so then our final answer, I guess we won't get our final answer immediately, but let's write it down. So our V hat, you remember that just means the unit vector. It's going to look like this. You take your x component and you divide it by the magnitude. We're scaling it back. And the y component and do the same thing. Now, technically, we can simplify that, can't we? So do y'all agree the 2's will cross out? So we'll be left with Now, some of you might be asking yourself, why are you leaving a radical in the denominator? We do not do that. And actually, the answer is we actually can here. Just because we're trying to get the point across that you're dividing by that magnitude. So just simplify the whole numbers and then you're done. Now, I want to show you what it means by verify. Okay, because this is kind of cool. All right, so I want to verify that this answer here actually does have a magnitude of 1, like that I did it correctly. So basically, I want to show that if I do Pythagorean theorem with these values, that it will give me 1. All right, so let me show you what I'm going to do. I'm going to do Pythagorean theorem with these components. And we should end up with a magnitude of 1 if we've done it correctly. Okay? So square the numerator and square the denominator. Right, so a squared, if we square -1, it'll be 1. If we square a root, the root goes away. Okay? And so then square the numerator. 1 squared is 1. Square a radical, the radical goes away. And now what is 1/2 plus 1/2? That's 2 halves, which is just 1 whole. And what is the square root of 1? 1. Now I can put a check. Do y'all remember back when we did the trig identities? It was like the last, or really technically I guess the first thing that we did during distance learning was our test over that. Remember when we would verify like that one side equaled the other side of the trig identities? It's not really that you kind of know what the answer is. The point of verifying is to get to the answer. So here when we verify, we're just trying to show that what we did was correct, meaning that the magnitude will equal 1. But technically what the final answer is this right here, okay? All right, that is your final answer. We didn't have to verify in 39 because the magnitude was clearly 1. We could see that in the picture. All right, let's look at 43. So let me go back. 39 and 41 were in component form with the pointy parentheses. 43 is in I and J form. But do we agree that we could change this into component form, right? So what is another way of writing I and J? Well, I goes with the X and the coefficient is a 1 here. And J goes with the Y and its coefficient is 1, 2. And they're both positives because there are no negatives. So notice I went over to the right 1 and then up 1. So here's my right triangle. So is it a unit vector? Some of you may say, yeah, it's a unit vector because the sides are 1. But if you think about Pythagorean theorem, our magnitude of this v is not 1, because if we do 1 squared plus 1 squared, we actually get 2, and the square root of 2 at that. So we do not have a unit vector, so we need to scale it back. So how do we scale it back? We divide by itself. So we're going to divide this by the square root of 2, and then we'll get 1. We have to divide this by the square root of 2 and divide this by the square root of 2. Because if we do it to one side, we have to scale it back to all of them. So our final answer is v hat is just going to be 1 over root 2, 1 over root 2. So we take our original problem and we divide it by the magnitude. All right, now I'm going to verify, which I think y'all will see it's the same as the previous one. I'm going to verify that it's correct, which means I'm going to do Pythagorean theorem with these two numbers that I think are my answer, and it should equal 1. So it's 1/2 plus 1/2, which equals 2 halves, or 1 whole, and the square root of 1 is 1. Check. Okay? All right, now let's go to 45. So 45 is kind of a nice one that it's, oh, and I meant to say, back here, here's your actual final answer. You can write it in I and J form or in component form. I don't care. Okay, so another way you could have written this is you could have said I over root 2 and then J over root 2, because that's an, oops, I didn't mean to put a comma, sorry, plus J over root 2. Okay, these two things mean the same thing. I just think that doesn't look as nice, but that's fine. All right, so with 45, it's a little bit easier one because it's perfectly vertical. So what is the magnitude of this vector W? The magnitude of W is 4, right? That's how long it is. So if we want to scale it back, you just divide by 4. Okay? So then we have a magnitude of 1. So W hat is just going to be, instead of 4J, we're going to divide it by 4. And so we're just going to have J. And do y'all agree that we just learned a minute ago that J is the same as the Y direction? Okay, what's another way we could write this? In component form, 4J could have been written as I had nothing, there was no I, and then the J would be 4. Okay, then you could divide each of these by 4. And so another way to write this would be 0, 1. These two things mean the same thing, J and 0, 1. Okay? We don't need to verify that because you can literally see it in the picture. It's 1 unit long. Okay, so now that's kind of I hope that's enough to help you. The only thing I guess that's a little different is these are negatives. So just make sure you're going, all 3 of these, or 4 of these actually, are negative. So just make sure you're going in the right direction. Remember, negative in the Y position means you should go down. Negative in the X direction means you should be going left. Okay? And then the last set says, it doesn't say to do all of that. It doesn't say find a unit vector. It just says, the initial and terminal points of the vector are given. Write the vector as a linear combination of I and j. So you guys, basically it's just asking us to write it in terms of I and j, and that's it. Okay? So I've done this one kind of already, or kind of talked about it already, but basically you just want to get it into component form. So 2 ways you can figure out the components. You can do terminal minus initial, so 3 minus -2, and then -2 minus 1. And that would give me 5, -3. Now I'm going to double check that because I have graph paper here. So I sketched my initial point at -2, 1 here, and I sketched my terminal point here at 3, -2. So does this 5, -3 pan out correctly? So 1, 2, 3, 4, 5, 1, 2, 3. Yes. So I went to the right and then I went down. Now, it said put it in I and j form, so we now can turn that easily into our final answer. So remember, the 5 goes with the I, because it's the X, and then the 3 goes with the J. Now, this is a -3, so instead of putting a plus between them, you're going to put a minus. And that's your final answer. It's as easy as that. Okay? So don't try to make it more complicated than it is. Basically, if you can get into component form, finding a unit vector and then writing it in I and j form is also fairly easy. But I know it can seem a little confusing. So what is boxed up is what you're going to be putting as your answer. You don't have to show the verify, but I think the verify might be helpful in some instances. Okay, so if you will try these 44, 42, 40, 42, 44, 46, and 54, I can give you some feedback on those. Okay? Awesome. Y'all have a great day.